I'd like to show you an example of how you can use a u-substitution to help you solve a definite integral. So consider this integral, the integral from 0 to pi over 6 of cosine to the minus third power of 2 theta times sine 2 theta d theta. Remember that this is the same thing as this integral where the cosine of 2 theta is really being raised to the power of minus 3, so that's just notation. And then it's times sine of 2 theta d theta. So I see a composite function here, and this is usually an indication that I might want to try u-substitution. So here's our integral again. Now let's look inside the composite. We have cosine 2 theta being raised to the minus third power, so I'm going to try to let that be u. So I'm going to choose u to be equal to cosine of 2 theta. Remember, when you're doing u-substitutions, you get to make a choice for u, but then you need to calculate du. And remember that du is going to be the derivative of cosine 2 theta times d theta. So du is equal to minus 2 sine 2 theta d theta, because the derivative of 2 theta is 2, and the derivative of cosine is minus sine. So now I have my u and my du. I can rearrange that because if you notice, up in my original integral, I need something for sine 2 theta, so I'm just going to divide both sides of the du equals minus 2 sine 2 theta d theta by minus 2, and I get minus 1/2 du is now the same thing as sine 2 theta d theta. So there's my u, and then sine 2 theta d theta is going to be minus 1/2 du. So here's the integral again. So I'm in good shape, but I have one thing I need to consider. Those limits over there, 0 to pi over 6, were limits for theta. And I'm changing my integral to u, so I need to find the appropriate limits for u. And the good thing is that there is a relationship now. I know that u is equal to cosine of 2 theta. So if I know theta, I can find the corresponding u. My lower limit is theta equals 0. I plug that into the u equation, so I have cosine of 2 times 0, which is of course cosine of 0, and that's 1. My upper limit is pi over 6. I'm going to plug that into my u equation. I've got u is equal to cosine of 2 times pi over 6, which is the same thing as cosine of pi over 3, and that equals 1/2. So my lower limit, when I turn my integral into u's, it's going to be 1, and my upper limit is going to be 1/2. So let's see what that looks like. So I have now the integral from 0 to 1/2 of u times the minus 1/2 du. And you can see that those are direct substitutions that I've made from before. And I'm going to move that minus 1/2 to the front, so the integral that I need to solve to take care of this problem will be minus 1/2 times the integral from 0 to 1/2 of u du. So of course the integral of u du is u squared over 2. So my definite integral looks like minus 1/2 times the quantity of u squared over 2 evaluated between the lower limit 0 and the upper limit 1/2. I carefully plug that in as you see there, and when I simplify, I get that that integral is equal to minus 1/16. So this means that the integral from 0 to pi over 6 of cosine to the minus 3 2 theta times sine 2 theta d theta is equal to minus 1/16. And so that's how you can use u-substitutions to help you solve definite integrals.